Want your compiler to help catch bugs before they happen? There is a small but powerful C++17 attribute that does just that, if you know how to use it. Let's dive into the fallthrough attribute and how it can save your switch logic. Hello everyone and welcome to today's video. In this episode, we are going to dive into a lesser known but very useful feature in modern C++, introduced in C++17, the fallthrough attribute. If you've ever written or read a switch statement in C++, this one is for you. Let's start with a bit of context. In traditional C++, switch statements can sometimes behave in ways that are surprising to new developers. Specifically, if you forget to put a break statement at the end of the case, code falls through to the next case, often unintentionally. Here is a quick example. Now, you might expect this to only print 1 when value is 1, but instead it prints both 1 and 2. This is because there is no break after case 1, so execution falls through to case 2. Now, sometimes fallthrough is intentional. Maybe you want multiple cases to share logic, but other times it's a bug. Prior to C++17, we just had to rely on comments like, "Hey, this is a fallthrough," to tell readers and ourselves that it was on purpose. But here is the problem. The compiler doesn't understand comments. That's where fallthrough comes in. With C++17 and onward, we can now explicitly tell the compiler that a fallthrough is intentional using the fallthrough attribute. This makes our code more expressive and helps the compiler catch bugs. Let's take a look at the same example but updated with fallthrough. Here, we've used fallthrough after case 1. This tells the compiler, "Hey, I meant to fall through here." So now if we forget to add fallthrough and don't put a break, the compiler can actually issue a warning, depending on your warning level and compiler flags. Let's think step by step about how this improves things. First, it improves readability. Anyone reading your code knows you didn't forget a break. You actually meant to go into the next case. Second, it improves safety. If you fall through by accident but didn't include the fallthrough attribute, the compiler can help you catch it. Third, it gives you more control over how your switch logic flows, which is especially helpful in large functions or systems with many condition branches. Now, here is something important to remember. The fallthrough attribute must be placed on its own line, and it must appear just before the next case or default label. Also, it only works within a switch statement. If you try to use it anywhere else, like outside a switch or after a return, you will get a compile time error. Here is a real-world use case. This example shows how we can stack behavior logically, while still being clear about what's intentional. Before C++17, all you had was a comment and a hope that people understand what you meant. Now you have the fallthrough attribute, which makes your intent explicit and your code safer. To sum it up, use fallthrough to clearly mark intentional fallthroughs in switch statements. It helps compilers warn you about accidental logic bugs. It improves code clarity and communicates intent to other developers. It's available starting in C++17, so make sure your compiler supports it. That's all for today's video. I hope you now have a solid understanding of what fallthrough attribute does in C++, why it matters, and how to use it effectively. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe and check out the playlist on the screen. See you in the next one.